Hello, everyone, and thank you for joining us for today's Climate Action webinar, Induction Cooking, the All-Electric Kitchen of Today in Zero Net Carbon Design for Food Service. AIA California recognizes that the planet is experiencing an urgent climate emergency and that California should continue to elevate its position as a global leader in addressing the grave challenges of advancing climate change. To help do this, AIA California has developed an in-depth educational climate action webinar series that incorporates the AIA Framework for Design Excellence and includes zero net carbon design education. To qualify for continuing education credit, AIA California provides the learning objectives for each webinar and includes them in the PDF presentation that can be made available online. Today's session also qualifies for zero net carbon design mandatory continuing education. A certificate of completion will be provided to those who stay on and fully complete today's webinar. A few quick housekeeping reminders. Today's session is being recorded and will be posted on the AIA California website, www.aiacalifornia.org, along with any additional resources shortly after today's session. Today's session qualifies for one AIA HSW learning unit for those watching live, and AIA California staff will report these units for you. Please use the Q&A function to ask any questions for today's presenters. You can also like a question to move it to the top of the queue. Questions that are not answered in the webinar can be made available on our website. I'd now like to introduce our moderator for today's webinar. Miranda Gardner, Associate AIA, is a Vice President and Sustainability Leader at HKS, with projects ranging from campus to commercial mixed use. Her career has afforded her multiple international experiences, including fieldwork in Greece, a research fellowship in Germany, and a secondment with the Abu Dhabi Urban Planning Council. Previously, she managed lead technical development at USGBC, including lead for healthcare and lead pilot credit library. Miranda serves on the board of directors for the San Diego Green Building Council and AIA Los Angeles. She's a member of USGBC's Lead Advisory Committee, Green Builds Advisory Board, chairs COAT for AIA LA, and related to today's topic at hand, was part of the leadership team for the Building Decarbonization Practice Guide, a zero carbon future for the built environment. She holds a Master of Architecture from the University of Pennsylvania and a BA from Georgetown University. Miranda?
Thank you so much, Sarah. Hello, everyone, and welcome to today's program, Induction Cooking, the All-Electric Kitchen of Today, ZNCD for Food Service. This program will discuss how induction cooking and holding work, benefits and challenges of induction cooking, and how you can access resources and incentives to promote electric kitchen. Plus, there will be a show and tell video on induction cooking at the end of the presentation you won't want to miss. I'd like to take a minute now to introduce our speakers. First off, Richard Young, FE3. And if you don't know what FE3 is, it's Food Service Energy Efficiency Expert. It's an online, on-demand training created by our presenters. Richard is the Director of Outreach at the Frontier Energy Food Service Technology Center, sometimes known as FSTC, an unbiased commercial food service research and training facility known to most industry insiders as Fishnick. Trained as an electrical engineer, Richard shifted from power generation to energy efficiency over 33 years ago when he joined the research team at Food Service Technology Center. He is recognized as one of the most knowledgeable people in the USA on efficient food service design and operations, and spends most of his time on outreach and training, translating the center's 34 years of knowledge into practical and useful information. He has created and delivered over 1,000 presentations and classes and authored numerous research reports, and articles in magazines, newsletters, and on the web. He is also the creator and author of the online Food Service Energy Efficiency Expert, FE3 training, as I just mentioned, and certification program, and information can be found on this on www.fe3.com. Our other speaker today is Chef Mark Duesler, FE3, graduated from the California Culinary Academy in 2004. Chef Mark's restaurant experience includes notable venues such as restaurant at Wento, Miro, and Spa Cafe. He has 20 years of independent and fine dining restaurant industry experience, with 15 of those years running kitchens, giving Chef Mark firsthand knowledge and expertise relevant to the aspects of food service industry. Chef Mark currently manages the Food Service Technology Center's extensive library of high-tech cooking prep, holding, and refrigeration equipment, including the nation's premier collection of induction equipment. Chef Mark will give an overview of how induction cooking works today in today's all-electric commercial kitchens to create a zero-carbon kitchen. Richard, Mark, take it away.
Great, thanks everybody. And let me share up a screen here and we'll get rocking and rolling. And share, there we go. By the way, everybody, I first met Miranda, I don't know how many years ago at the USGBC in Washington, DC. And I could tell she was super smart, and I'm just thrilled to see she's now a vice president for HKS. So that's just awesome. Keep up the good work. Mark and I have a ton of information to share with you today. I got a lot of slides. I'm going to move quickly through these slides. The good news is that this is recorded, so you can always go back and stream it again. And also I'm working on a companion blog article that will be posted on the AIA website as well. So trying to get you as much information as fast as possible. And let's take it away. And you've already met Mark and I. One thing I want to mention is that our food facility, the Food Service Technology Center, is a fuel agnostic, mission driven team. And anybody that spent any time with us, you'll understand very quickly what we mean by mission driven. We're very focused. And that mission is cutting carbon. Okay, we're just trying to cut carbon as fast as possible and in the best ways possible. So I need to point out that these offerings are funded by California utility customers. That's you, and administered by PG&E under the auspices of the CPUC, which is awesome because these are public dollars coming back to do public education. Because this is a PG&E sponsored class, we do like to do a quick safety message, and my message is about distracted driving. And in the time that it takes you to read this little blurb here, sending or reading a text, et cetera, that's about 5 seconds. That's the same as driving an entire football field with your eyes closed, right? So I know that none of you listening are actually driving with a phone in your hand, because I think you're a really great audience. But the thing that I've seen people doing is all around me, people driving with phones in their hands. So I put this up here just so you'll be more defensive in your driving, especially out on the highway. I just see this a lot. We would like to do something, and that is to capture some names, because once again, this is funded by the CPUC just for our reporting purposes. So there's a little QR code. If you could just take your phone and hold that up there, it's less than a minute to answer a couple of questions, your name, your zip code. This just goes into a secure link that PG&E uses to report numbers back out to the CPUC. And for those people that are listening to the recording and are not with us live today, I'd appreciate it if you would do the same thing, because every head count counts. And our goal is to make sure that the CPUC knows we're spending your public dollars wisely and everybody's showing up. So hopefully everybody's got that QR code, and let's roll into the next bit. And I believe also that Michael Kars, our tech guy, was going to put the QR code into the chat as well, in case you missed this one. A couple of other important housekeeping notes is there's a short survey that PG&E would also appreciate you taking, very, very quick. The link to that is in the chat. Also, as we mentioned, I'll take today's presentation, all these slides, print them into a PDF, so there will be handouts, and there will also be a recording of this presentation, so you can go back and get all this information, and that'll be on the AIA California website. And then finally, if you have any questions, type them into the Q&A box, and we'll try to get to those guys as we move towards the end. But let's leap right into it, okay? So let's talk about Zne and Znc for commercial kitchens. That's my intro piece here. And the first most important thing to know is that commercial kitchens are super energy intensive. And as you look at our diagram here, you can see here's your restaurant, and compared to, say, lodging or retail, when you're looking at the kBTU per square feet, or the EUI, typically 5 times more energy intensive than lodging, say 7 times more than typical retail. And actually this number, this 350 kBTU per square foot is really a very conservative number for food service. It tends to be much higher, particularly if you're talking about something like a quick service restaurant. Those things can start at 600 and go up well above 2000 kBTU per square foot. And I mention that because that creates a huge challenge for anybody that's trying to do any kind of zero net energy work in commercial food service. I'm going to tell you right off the bat, probably not going to see that. Okay. And here it is. Here's an example of that. Here's the bullet building, which I think most of you have heard of. And in order to get to the zero net energy of the bullet building, you have to get down here at about, 12 as your kBTU per square foot, right? Is your EUI, pretty low number. All right, let's compare that to food service. Here's the average EUI. I just showed you at 350, and here is, say, a quick service restaurant at 800. So if you're going to try to go from here to here, that's going to be really tough, right? So that's why you're probably not going to see many ZNE food service operations. They're going to be very, very specialized. One example of that, a very specialized ZNE, is this McDonald's one that was built down in Orlando, Florida. Basically, this whole thing, all of this huge superstructure is PV. That's all your energy generation. And down here in this little box somewhere in there, that's your process loads, okay? Gives you an idea of the ratio of PV to process loads for commercial food service. So, I'm willing to bet that this will be the only Z&E McDonald's ever built. It was a great project. We actually consulted on this years earlier when working with RMI, and just knew that it was going to take, an awful lot of PV to make this thing happen, and a very efficient restaurant. You may see more of this. This is a zero net carbon McDonald's. This is actually in the UK. You can see they've got some PV up here and some PV there, and then a couple of turbines here. Actually, all of this is generating maybe 20% of their on-site energy needs. So definitely a long ways from being Z&E, but what they're doing is they're making up for the rest of that by buying credits, clean energy credits. That's probably what you're going to see the most of. You're going to see zero net carbon restaurants. So that will be our focus. And once again, there's the process load. It's a small part of the building. I just took this photo last week. I was down in Anaheim and I looked out the balcony and I saw all these wonderful PV panels up here. And I was like, wow, look at that. I think that's great. That's the future. Let's put these on flat roofs. And then I realized, oh, this is a perfect picture for today's class, because you see right here where there's no PV, that's the roof where all the food service is. And there's just a lot of junk up on the roof, which once again means that it's very hard to put any kind of on-site PV on top of a food service operation. Just probably not going to see it, even though I think the energy codes are requiring some of that. It's not a great way to go. Some of you have probably seen this pathway to carbon neutrality that SCE put together. It's basically first thing, you decarbonize electricity. Then the next thing is electrify transportation. The next thing is to electrify buildings. That's where we are today. Then you move to low carbon fuels and trying to sink that remaining carbon. It's the electrifying buildings with clean electricity is the pathway to carbon neutrality for commercial food service. That's probably the one you're going to see as the most practical pathway. And once again, that explains why municipalities are pushing forward with their electric reach codes. This is the one that sort of makes the most sense. Doesn't have to be this way, but with the view that we have, this is the way that matters. So that brings us around to this notion of all electric commercial kitchens. And what does that look like? And is this some kind of unicorn? And electric kitchens have been done in the past. It's not a unicorn, but it is not typical, particularly in California. And it's because of the difference in fuel cost. More than anything else, natural gas is a low cost fuel. Also, if we're going to try to move towards the all electric kitchen, we need to start thinking about a more holistic design as well. So if you've got a design project and the client's saying, let's go all electric, the very first thing you have to start thinking about is, how do we reduce size? How do we deal with labor issues? What technologies can we use? And really the whole notion is to try to do more and less space with more high tech and automated equipment, and with from a social equity standpoint, to try and put professional kitchen staff into that kitchen instead of, low paid revolving staff. Basically what we're talking about for our American kitchen of the future, which is all possible and doable right now today, is kind of like a European kitchen of today. They already have a lot of this going for them. This is a big money slide for you guys. This is like the pathway. This is all the things that have to go into our holistic design to make all electric kitchens go. And we could spend hours just talking about this list. I just want to get this in front of you so you can see what it all entails. But it includes, starting right off from the very beginning, smart high-tech equipment like combination ovens and rapid cook ovens. If you don't know what those are, I'm actually going to show you some resources where you can go take a bunch of classes where we demo and describe all of this kind of good stuff. High efficiency cooking, holding, refrigeration, and sanitation equipment. Food service is an industry where people routinely buy low efficiency equipment. We have to move towards high efficiency equipment. That is the fastest, cheapest way to decarbonize that kitchen. That's a top priority step. Then we need safer, faster equipment like induction cooking and holding, which is what we'll be talking about today. We need to try to start moving our production off peak, because those demand charges related to electricity are really crippling to an operation that's going to be doing prep and serving between those hours of 2 and 9 p.m., right? So we need to look at automation, cook, chill, sous vide. These are all techniques that could allow us to spread our energy use out over 24 hours. Demand controlled kitchen ventilation should be in every single project where it makes sense. It doesn't make sense everywhere, but that is a great way to cut your energy use in half and your carbon in half. Advanced plumbing design with heat pump water heaters and HVAC with heat pump space heating. I have put arrows next to these because almost nobody in the food service world is doing any heat pump space heating, and virtually zero people have ever done any electric heat pump water heating. We're still looking for some good case studies on that. We know how to make that stuff work, and in fact, we're doing a class next week for SoCal Edison where we talk about heat pump water heaters, but we need some case studies. These are some serious technology challenges that have not been well discussed within or well proven within the real world. We need some case studies. We need to teach people how to do this stuff. So this is something you really need to pay attention to if you have projects. And I think this is another money slide. This is one of the biggest things that I've seen, and one of the real things that's dragging down our decarbonization efforts and our all electric efforts. And it is the structure of how designers and engineers and food service operators and food service consultants work with the client. Okay, so let's start with a client. Let's say this client is a high-tech company. This is one of the situations where I see this, a Microsoft, a Google, a LinkedIn, whoever. And so the client wants to build a new building, and the first people they're going to talk to are the architects, engineers. They become the primary contacts, right? And sadly, most architects and engineers know almost nothing about commercial food service design. And even some of the best ones I see make routine mistakes. We're trying to unwind a mistake right now at a high-tech kitchen. So you got your client, the architect, engineers, and then probably the next layer is going to be the food service operator. The clients, particularly if it's a big operator, they probably already have a food service operator they're working with. And that's like an Aramark, a Sodexo, somebody that is buying the food, running the kitchens. Then way out there kind of is the last person in the chain, or somebody who's kind of forgotten, is the food service designer. And my pitch is they need to be right at the beginning, included in every project, and moved right up to the front, and really interfacing directly with the architect, engineers, and client. Because what I see is this separation between the food service operators and the designers, and the food service designers get pushed off to the side. So what we end up having is a siloed design team, and then you throw in purchasing on top. And so you get a siloed design team, and then you get value engineering, and what you get is crappy kitchens. So the best intentions of the client to go all electric or to cut carbon then get screwed up, because we start pulling out the efficient equipment. We start adding in things that the food service designer did not even know about. And that's where routinely, from our 35-year experience at the Food Service Technology Center, this routinely causes failures of kitchen energy efficiency. It breaks our heart again and again, and we've seen it at all levels, from mom and pop restaurants all the way up to the biggest high-tech companies and universities out there. So stressing here, you must bring in the food service consultant early, have a plan, and make sure they are part of all the design work. Okay, architects, you listening to me? All right, thank you. Everybody raise your right hand. I promise I'll bring in the food service consultant early. there's ways to do this, but we got to get everybody on the team and use the best technology. And I love this photo. I took this up in Seattle and I saw these ovens and I saw the wood underneath and I was thinking, wow, you know, are you guys, you're using wood burning ovens up here? And the pastry chef said, no, these are all electric ovens. And if you look at the edge of the oven, they're actually run with these, you know, high-tech panels. These are very high-tech German all-electric ovens, and he absolutely loves them. But they did a little trick here by just making them look like a traditional wood-burning oven, right? So all this stuff is possible. It's just, you know, changing habits and getting people on board. So let's talk about some of these, you know, things, some of these challenges for food service designers and operators. That first one that everybody worries the most about is behavior change. Okay, we have to take these grumpy chefs who have worked on the same equipment, you know, gas equipment in their culinary schools, and now try to get them to use induction and electrification. It's interesting. We talked to lots of chefs and operators who don't seem to have a problem with that. They're happy to move over to electric. We talked with some other ones who are like, no, I don't think I can do it. But typically it comes down to the fact they're not familiar with the technology. You know, it's a conservative industry because nobody wants to have somebody point a finger and say, you know, you broke the kitchen. You didn't get the food out fast enough. The food didn't taste good enough. You know, nobody wants to do that. But anyway, the behavior change piece, I think, is the smallest of our challenges. Everybody seems to think that's the biggest challenge. In my experience, I think that's the smallest challenge. The real challenge is that electricity is a more expensive fuel than gas. Okay, that's our biggest challenge, and that the rate structure does not favor commercial food service to go all electric. Hopefully that rate structure changes. If you can do a really good holistic design, you can try to levelize those costs out so that your electricity doesn't cost that much more. If you have a big project like a university or a high-tech company, then that differential cost between electricity and gas is not that big a deal. But if it's a mom and pop or it's an independent operator, this is a real challenge, okay? So it's something we need to pay attention to and try to work around. When it comes back to that behavior change thing, I can tell you what, you know, a big chunk of that challenge is already met because every quality manufacturer makes, you know, a gas and electric griddle, a gas electric fryer. They're pretty much equivalent in cost and productivity. In many cases, the electric equipment is producing more food than the gas equipment, right? It actually performs better. But a person working on the cook line, a cook would not know the difference between a gas and electric griddle or a gas and electric convection oven. So you could, all of these pieces of equipment could go all electric today and nobody would ever notice, right? So that handles half of our challenge. Another way to overcome these challenges is that naturally kitchens are moving towards more electricity because all of the new high-tech stuff, those little rapid cook ovens, they are all electric. So there's already a trend in that direction for all these new kinds of pieces of equipment. And then the thing that is going to absolutely make this possible is that induction is a superior technology. We have induction cooking that we can use. And induction is the key to this thing. And I will just say this as well. If you have a project and they want to go electric, and I've seen this happen, you want to use induction cooktops. Do not let anybody on an all-electric project use the old school electric range tops. Those things stink, okay? And if we didn't have induction, we'd have a real problem trying to move towards all-electric kitchens. But induction is the key to this thing. Induction is really a disruptive technology. Super fast heat up, great temperature control. Because you've got great temperature control and less burning, there's less reduced food waste, super fire and burn safety, reduced kitchen heat, you know, radiant heat out in the kitchen from induction, and super easy cleaning. I mean, not only is it a technology that allows us to move towards an all-electric kitchen, it really performs so much better than the traditional technologies. It's just not even funny. Let's do just a quick discussion of how induction cooking works, just in case people don't know the technology behind it. You have this copper coil that sits underneath a ceramic glass top, and we're running electricity through that coil rapidly back and forth, and it creates a magnetic field, which is our purple lines here. They go perpendicular and up just up above the glass top, and that magnetic field is not able to do anything. It's not using really any energy until we put a magnetic pot or pan into that field, okay? Then that magnetic field basically vibrates the electrons, in that pot or pan back together. It's kind of like rubbing your hands together. And so it generates heat in the pot or pan. It's the cookware that gets hot and not the surface. So what we end up with is an extremely efficient transfer of energy and very controllable. So I love this. This is a couple of infrared shots from the Volrath company, which is a manufacturer of induction cooktops. And this one on the left is our induction cooktop. And in this case, if I put $1 worth of energy into my cooktop, 85 cents worth is actually making it into the pan and making it into the food, okay? And I love this because you can see that heat zone right there. And that's basically, that's the magnetic field. It's very uniform and there's no heat going anywhere else. Also, you notice that the handles are cooler than they normally would be. The one on the right is my gas range top. In this case, I put $1 worth of energy into the range top and only 35 cents actually makes it into the food. It's a pretty low efficiency technology. And this 35% is generous. That's 35% on a good day with everything working right. And you can see the difference. The reason that we lose so much energy is because it's going up the side, right? You can see all this heat that's rippling up. You also see, more heat hitting up here around the handles. So, and then of course you see the whole burner pad there is just red hot. So those are all sources of waste heat out into the kitchen and waste heat that never makes it into the food. So that's why, once again, induction is so good. And here's another great thing, it's got some natural energy efficiency built into it. You pull the pot or pan off and the cooktop is not using any energy. So there's a safety factor and an energy factor. You don't have an idle rate on an induction cooktop. It's either on and working, doing some valuable work towards cooking food, or it's off. From a safety standpoint, you can see Chef Mark here. He puts a napkin underneath that saute pan and it doesn't catch fire. He's cooking fish, which is actually quite delicious, by the way. And, it's because, once again, all of the heat is going into that pan. There's no residual heat coming off the top there. So you end up with a greatly reduced fire risk because you've got no open flame and a burn risk. You also notice that Chef Mark here was handling the pan with his bare hand. Because you don't have all that waste heat that's coming off, around the pan, the handle does not tend to get as hot. So you've also got a little safety aspect there. And then of course the ease to clean after he has made his very buttery fish, his heart healthy buttery fish, and it's splattered, butter everywhere. This is all it takes to clean up. Very nice. I actually used my own countertop induction cooktop last night. I made lemon curd with Meyer lemons off the tree in front of my house. It is incredibly delicious. I call it lemon flavored butter sugar. That's kind of actually what it is. But, it took me no time to clean up afterwards, just wipe down the cooktop. And for a rank amateur cook like me, the induction cooktop is just so much easier to use. Like I needed to melt butter. I put my little pan on there. I set it on 100 degrees. I went off and did everything else. And I didn't have to worry about browning that butter, melting it too fast. And then as I'm mixing my curd up, the magic temperature is 180 degrees. You don't ever want to boil a curd that wrecks it, right? I just put it at 180 degrees and I stir it and I don't have to worry about it. And I can go off and do other things because I know it's not going to overshoot. When I use my gas range, I always overshoot. I end up burning the butter and all this good stuff. So love the induction for all of those reasons. Great technology. Here's a shot from our demo room in San Ramon. If you have projects and you have customers who are saying, I don't know if I should go all electric, contact us, send them to us. Chef Mark will do a demo with them. Here are a couple of the full-size induction cooktops, and then here is an induction wok. Let me show you a couple of pictures from a brand new high-tech kitchen. These are some of the combination ovens that we preach to have people use. They're extremely flexible ovens. And then here you can see a couple of the bigger cooktops, and down here at the end, an induction griddle, right? And I think one of the nice things about this from a design standpoint is this equipment is much lighter and more portable. You can see everything's on wheels. It can all be rolled out and cleaned behind. It's easier to reconfigure things if you need. It's just really a technology of the future. Another image here, suppose you're cooking chicken breast or a steak or something, and you want grill marks on it. This is an induction griddle with these grooves into it, so you can actually get some grill marks. Here's another shot of a similar kitchen where you've got an induction cooktop next to the grooved griddle. These are induction soup warmers. These things cut energy use in half, and even though they're small and they're not using tons of energy, you think about the 100,000 soup warmers in California. This is a huge way to cut carbon and get better performance. And I also want to show you this. This is a little mini combination oven. This is one of the coolest pieces of equipment on the planet. It can cook everything, do it quickly, and with tremendous flexibility. So these are all tools that go into that all electric kitchen, and all these technologies are available today. We're not talking about 5 years, 10 years. All of this is available. Another sort of great general kitchen here. We've got a very high-tech griddle, which is not induction. Not all pieces need to be induction. In this case, just the regular electric griddle as is so well designed that it's super efficient and super uniform. And you can see an induction cooktop there and more combination ovens. And then the other cool thing about this from a design standpoint is we can use all that space down underneath the induction cooktop for some lowboys, for some refrigeration, which cuts down on the number of steps that the kitchen staff needs to move and can increase our food quality and food safety. So all of this, brand new kitchens in the real world, all electric kitchen, this stuff is happening today. And then this is a shot because typically the big challenge people ask about is woks, and induction woks are a challenge from a supply standpoint in the US. There's one manufacturer out there, there's another manufacturer that's coming on. I anticipate lots more induction woks, but the full scale woks, and certainly the tabletop woks have been around forever. But for the full size woks, that's one of those things people ask about. But from a standpoint of can they be used for cooking, Asian cooking? I took this photo in Shanghai in 2014, and so here you see the full induction suite, stock pot range tops, and a full size induction wok down there. So I figure if it's good enough for Shanghai, that we can use it in the United States. So now what I'm going to do, we had thought we might be able to get into our demo room and have Chef do some live cooking and stuff, but that didn't work out. We had a conflict. But what we have is basically the same thing. It's just a video of the last time we did this with Chef Mark. And so let's look at Chef Mark and have him wander through and show us all these beautiful pieces of equipment. And hopefully my audio will work. You guys will tell me very quickly if for any reason it doesn't work. So let's leap in.
Started out with less intense to more intense, and then a few pieces within that. This here is just your simple 120 volt unit. Many of you have probably seen them. The nice thing about them is you can put them on a table. Pastry kitchens use them quite a bit, right? Because you can cook by temperature. You don't need double boilers. They're very even in their heating. But if you're going to be doing a lot of like heavy saute work or things like that, this is probably not going to be the unit you're going to want to use. It's going to be a little bit underpowered. But they are good as just maybe an add-on to what you're already doing, and then you can of course put them away. So as more of a convenience factor and being able to add a little bit of versatility to the kitchen, this works really well. Hot cooking really is just, if you think about it, it's kind of a one-pan meal. Now this unit here is of course designed more for like if you had an action station, or if you're doing some type of wok cooking for show or light saute work. And the reason being is that you're using a dial rather than like a traditional, you need both hands to do that work. But what's neat about these is this is actually incredibly powerful. So this unit here is about 1800 watts, so 1.8 kW, 1000 watts. This here is 5000 watts, so very, very powerful. It's misleading because, look at the size to be able to do that in like in a gas range setting, or even in your electric resistance, which would just be difficult with a wok anyway. It's going to take quite a bit more space to be able to get that same amount of firepower in such a small package. And the nice thing is that you can unplug these, put them away, and you've also added some versatility to your kitchen, or even your front of house if you're going to be using these as like an action station or something like that. Here we have, so this is 5 kW. This is actually doubling that up. So this is 10 kW, 5000 watts per hob. You can get different configurations. What's nice about these is that you can go back to front, right? So you can go longwise, or you can actually go horizontal. They can fit the need of whatever it is that you're doing. and it makes your process much more versatile in the sense of, if you need to expand or contract, you're able to do that. And these actually have feedback. So I would say when you're looking and specifying different models, you want to look at, what's its intended purpose. Yes, you could certainly use this to saute, but what becomes really important is you want to look at that interface, right? You want to see, how am I controlling this unit? And this unit here has 2 dials, right? Probably not like the most conducive if you're doing a lot of saute work. There's 2 displays here, which are also telling you, surface temperature, and also you have feedback. Right now I have these probe temperatures, so I can set my my unit to a certain temperature here on the probe. Why that's nice is that if I'm doing a lot of production work, and let's say I am making stocks or making broths, and I want to be able to control that, if I'm using a traditional gas or resistance element, as I said, as that volume goes down, it requires less energy to be able to achieve the same temperature. And then what ends up happening is you start overshooting that temperature. This is a great way to be able to control things like that. If you're making soups or stocks, you can control that temperature. You're not relying on your cooks to be able to have to do that work. And that ultimately is a labor saver, right? So now my cook can go off and do other things, and this is kind of working in the background. I have my machines working for me while my cooks are able to go do other work. This here is just an example of an induction griddle. So again, it's going to be a little bit more high power. This is about 5,000 watts here. But it's a very small, very powerful griddle. I think we've all experienced, especially if you're doing things like action stations. Excuse me. You have limitations when you have those small griddles. They just really can't keep up very well. In this case, you can actually have a griddle that's out. It's customer facing, or if you find a use in your kitchen, of course, that works as well. But again, you can move them around. They're pretty portable. And this one here will get pretty hot. I mean, you're up around like 550 degrees, and that recovery rate is really, really good. Here we would see more of a standalone range. So kind of something you would typically think of, like sitting on top of a chef base or something like that. And this is has more of the traditional controls, right? We would think of as like knobs on a range. And this would be certainly a good application for, swapping out like a line, right? You're going to be doing a lot of like line work, saute work. And they do have little indicators in here that tell you, the intensity or that power that the unit is using currently, but it's not going to give you your temperature setting. Some will give you both with knobs, but it's really going to be on the use case and understanding how the different units work and what their intended purpose is. A lot of people ask, or there's a lot of concern, and I was raised on gas ranges myself, and I've trained cooks that I know very, very well with induction. And in the beginning, there is a little bit of a learning curve, right? There is this frustration. Ironically, it's not that it's too slow. It's actually that it's too fast, and that they don't have that feedback, that visual feedback that we're used to, right? When we see a flame, we're able to kind of adjust. There's like a muscle memory there. One of the things that they have to get used to is, remember we were talking about that stability. And what ends up happening is when you do a lot of saute work, no matter what you're doing, you're usually kind of repeating the same process with slight variations over and over again. Maybe you're in charge of 8 dishes, or you're in charge of just meat or soup or whatever that might be, or heating certain things up, vegetables. And you're repeating maybe 6 different processes over and over again. And what we find ends up happening is they just start remembering the knob position rather than looking at the flame, which is nice because then they can just set it and keep moving. Now, where that becomes important too is like, so let's say I'm sauteing and this is a gas range. We rarely would start, with few exceptions, we would rarely start with a cold pan. So when we use a gas range or probably even electric resistance, we actually overshoot. We naturally know that we don't think about it this way a lot of times, but because of that inefficiency, we end up overshooting temperature because we know the pan's going to take a while to heat up. So let's say something comes in, we put our pan down right, we turn it on. Most likely, if it's going to be something that's pretty intense, we'll just put it on full blast because we're going to try and get that pan as hot as possible. Or we're taking up space somewhere else to keep these pans relatively hot so they're ready when we need them. Well, what we're doing there is we're just trying to shave down, right, that time, that heat up time, because we need that pan to start working quickly. Well, induction is incredibly fast because of that efficiency and because of the stability. I don't need to overshoot my temperature. Once I remember those knob positions, I can put the pan down, turn it to the knob position I want to preheat, and go get the ingredients just as I would with the gas range. But chances are when I come back, the pan's going to be exactly at the temperature I need. The other nice part about that is that when I put the items in, right, we usually adjust. We actually overshoot the temperature on purpose because when we put, cold items in there, they suck energy out of the pan, cools the whole process down, or cools the whole pan down and slows down the process. Whereas with the induction, we don't really have that problem. It'll actually maintain that temperature and maintain recovery. So what we actually find is people start reducing that heat because they don't have to overshoot and compensate for that inefficiency. Here we would see something similar in design, except this would be more appropriate for, if you're doing a lot more production work. So we have push buttons. Obviously, those would be more difficult if you're, working on a line. It is nice though that you do have the versatility. You could certainly use it for that. It's just not going to be as intuitive if you're working on a line and there's a lot of fast movement because of the buttons. But what you do have here is you have timers. You have you can cook by temperature. You can cook by power. And what this does is it really provides you more of a range for doing like production type of work, more of a traditional range that you'd think of as like the full 9 here, right? We got 4 hobs instead of 6 burners, so that is one thing to note. But the hobs are much larger, and you can actually share to some degree if you have smaller pots and pans. You can share each hob. Most of the units I have not seen any units with 6 hobs, and I think a lot of that actually has to do with how many amps it would require to put all 6 hobs in there. Here we actually have a full wok station. Now these are pretty new to the U.S. I only know of 1 or 2 that are here, but we definitely wanted to bring it in because it was apparent, in the very beginning, and I'll be the first to say I'm not a classically trained, wok chef or cook, but I'm of course very interested in it, and there's a lot of the same things that still apply. This is actually 12 kW, so it's very, very hot. But what we're really looking at there is not how hot it gets, it's actually how fast it can recover and get back up. Some other people have also said, well, the induction is very focused, so is that an issue where you're just going to have, heat only in one area? I would say not really, because, it does have this concave shape, just like the pan does. So yes, of course, the bottom is closer to that hob, but because it's sunken down, you still get that same effect, right? I mean, the nice thing about most woks is that they're already steel, so that's kind of that's a plus. So you're still getting that same natural, that heat coming up the sides. You're still able to use it in the same way. Here we have an induction buffet table. They use these induction pans. You can use, standard hotel pans. They're not going to work as well though. They just don't have the iron content. As you can see down here, I have 4 different controls, so I can set actually each zone to a different temperature. So I could put 2 half pans in here and be able to have 2 different items set at 2 different temperatures, which is pretty nice. And you don't get a lot of bleed through with that. Over here we have kind of a similar version to that, but a little bit smaller. What's nice about something like this is this is 120 volts. But I have the same idea here with 3 different zones. So I could put, 6 pans in here. So if I'm going to maintain sauces or things like that, the zones are broken up this way. So these would be the same temperature, these would be the same temperature, and these would be the same temperature. Here we have kind of a similar version. This is just a very low profile single hob unit. It looks kind of misleading. I think a lot of people think of it as being like that 120 volt, 1800 watt unit that we looked at in the beginning. But this is actually just more designed for heating. And then finally, here we have kind of a similar version. It's kind of a combination of these 2 things, and that would just be a soup well that's induction. The nice thing about the induction soup wells is a lot of them actually will retherm in the well. So rather than taking soup or whatever it might be, whatever liquid or you intend to put in here, rather than taking it over to your range or whatever it is, however you heat it up, heating it up first and then putting it in your bane, you can actually just put it directly in the bane. You select, soup. There's a touchscreen on here, just like everything has touchscreens nowadays. And you can hit, you hit retherm or, preheat or however you want to call it. It's usually retherm. And it'll actually heat this up to the desired temperature that you have. It'll even remind the cooks to stir it in the very beginning to make sure that it's heating up quickly. And then it'll actually hold at whatever temperature you want it to hold at.
So reason to show this, once again, is you get a sense of how many different form factors there are for induction cooking and holding appliances. And also, I just want to stress, I'm going to stress this multiple times, if you have projects, contact us, because we can help with consultations. We can look at equipment list, and Chef Mark can do demos for people on these various pieces of equipment. And we also have some res equipment as well. Now, Mark said he's not a big wok chef. He's not a classically trained wok chef, but let me show you a little quick clip here. Now, he doesn't cook this fast. I sped this up, but I'm showing this because it's lunchtime and I just want to make you hungry, and also just show you how well this wok works. And I was sad I was not there on the day that he that he did this cooking. But plenty of power. In fact, we're working with a U.S. manufacturer who is developing, you know, an onshore manufactured induction wok, full-size induction wok, and he's actually removing some of the power out of the wok, because he's finding, as Mark mentioned, he's finding that they're a little bit overpowered. He's actually trying to find that sweet spot where you have enough power to cook this delicious food without having to have, you know, a massive electrical panel, right? Because that's another one of those challenges, is how do we get the you know, the electricity into the building. So, oh, Mark, if I could just take a fork and reach into my screen, it's beautiful. Okay, so let's hit this last little piece here, is some resources, and then we'll go to some Q&A. So, most important resource, caenergywise.com. That's where we put all of our food service information. There's energy surveys. So, you know, if you know anybody that's got a facility that's actually open now and you'd like to have somebody walk through and help figure out how to save energy, we can do that. And this is funded by PG&E. Okay, so if they're PG&E customers, we have funding to come in and help these folks at no cost to the clients. We have design guides. If you're building new places, ventilation design guides, hot water design guides. We're working on a new updated hot water design guide. A lot of our brain trust is in there. It's all free. Use it. Seminars, if you were curious about what is a combination oven, what's a high-speed oven, what are ventless, if you'd like to see, you know, more about what Mark is doing on induction. Our seminars, we run these constantly. They're all free. We record the ones from past seminars. We post the handouts. We want you to use this information, and we want you to share it with folks. So get out and do that. Then we have the Try Before You Buy program. That's our demo program. That's Chef Mark's, you know, his heart and soul is into that, bringing people in, changing hearts and minds. If you have projects, there's also calculators that we can use to do ROI assessments. They're really simple and easy to use. They're also very powerful, and they're a good way to get that client to hold spec, because once again, value engineering is not your friend. Value engineering will produce a crappy all-electric kitchen, and then somebody's going to point a finger and say, I don't want to do this, or see, I told you I needed gas. And don't believe me, we're working through some situations like that. So do not value engineer, buy efficient equipment and hold spec, and work with that food service consultant to hold spec. That is the number one thing I see as a failure. And then, so you might be like, oh, well, Richard, you're asking people to buy efficient equipment. Doesn't that cost more? And yeah, in many cases it does, but in many cases it lasts longer. And in every case it performs better. But in order to incentivize people, we have, whoops, sorry, I jumped my gun there. To incentivize people, we have rebates, okay? And the rebates are very generous, and they're instant rebates. And I'll talk about that in a second. But getting back to this, this question of how do you get staff on board, we know that we need lots of hands-on training, both in the design phase and trying to change behavior. And then once the kitchen is built, you also must build in some training to teach people how to use these new pieces of equipment. But hands-on changes hearts and minds, and we see this happen. Folks who said, I can't do this, they come and they work with Chef Mark for an afternoon and they go, oh yeah, of course, I'd love to have this kitchen. I can do the all-electric kitchen. So definitely use that Try Before You Buy. Okay, here's the rebate program, and this is huge news. This program's been running just about a year. It runs statewide in California. It's an instant rebate program. And the notion is your clients go out, they find a participating dealer, which is most of the dealers in California. They purchase on a qualifying product, which is efficient equipment. There's thousands of pieces of equipment, and they just get an instant rebate. There's no paperwork. There's no sending anything in. The beauty of this program, it is a way to incentivize people and motivate them to buy the efficient equipment, because remember, efficient equipment is the fastest, cheapest way to cut carbon, okay? And I'm talking both sides, gas and electric. If you put an efficient piece of gas equipment into, say, an existing project, you can cut that carbon instantly in half. Efficient gas equipment is a great low-cost way to cut carbon. So both sides. I'm an engineer. I want to cut carbon. I'm not trying to do unicorn stuff. Let's do it right now. Efficient equipment is the best economic way to do that. Hopefully I'll beat that one to death and you'll say, yes, let's do it and let's get the rebates. Other resources, we have on-demand classes on the PG&E learning platform for both residential and commercial induction. Take those, share them with your friends. You know, it's a deeper dive into all of this stuff. And at the Frontier Energy Food Service Technology Center, which, as Miranda mentioned, it's lovingly called FishNIC because that was the name of our initial consulting firm. We have an induction technology page now with a bunch of resources on it. So that's at fishnik.com/ITC. And you can contact us about demos, training, project consultation. And we have an induction cooktop loaner program that we just started with PG&E. We loan out both residential and commercial. So contact us if you'd like, if you know somebody that wants an induction loaner that's a PG&E client, a PG&E customer, let us know. If you've got projects and you need some commercial loaners, let us know. We can hook you up with those, okay? Brand new stuff. So now we're at the Q&A. Big question mark. So Miranda, in our 9 minutes, I mean, we've hit you with a lot, but what do we got? What kind of questions do we have going here?
I was going to say, I think you've been answering quite a number of them, Richard, and I see that Mark's answering them in the chat as well. One of the ones that kind of consistently is coming up, I see in the Q&A, really has to do with residential. You know, we've talked about commercial kitchens here. How do we convince residential clients to do this? Is there, you know, a huge difference in what the residential equipment looks like versus the commercial equipment? And of course, have you heard of, you know, say a multifamily project that's been able to do this successfully?
Yeah, the residential equipment tends to look like a regular residential glass top range. Once again, all those performance benefits are there and then some, because in the residential ranges, they tend to build in a power boost on a couple of the induction hobs. So, you know, if you got a big, it's Wednesday night and the kids are screaming for mac and cheese, you can put a big pot of water on this big hob and hit the power boost and it'll just rock and roll. It'll get the water hot twice as fast as your gas range. And then, you know, when that water's boiling, okay, now I'm doing the cheese sauce and stuff, put it all together. And yes, you can tell I have 4 kids and yes, I have fed them, you know. But the way to get people, you know, once again, it's hands-on changes hearts and minds. So hook people up with our induction cooktop loaner program. And yes, multifamily is a great place for this. The biggest challenge with multifamily and induction is that a lot of those projects have a very limited budget for the white goods they can put into the kitchen. And so the developers are tempted to go with those electric resistance ranges, which are cheap and cost a lot less than induction range. Do not do that. Don't go putting that electric resistance range into a multifamily. Find some way to afford the Q&A. I'm sorry, the induction, right? Find some way to make that happen. It's just fair to the tenants and you'll just get better performance. And we are currently working with some folks that are working with multifamily developers, and they're going to bring them in for demos with Chef Mark to see some cooking on residential ranges. So that's another way to change hearts and minds.
Amazing, amazing. Oh, go ahead, Mark.
Oh yeah, I think from like a residential, like to the user standpoint, one thing that people are always trying to do is be more like a commercial restaurant, right? Or they want to cook like the pros. The cool thing about induction is it's a pretty level playing field. The performance is basically the same as what you would get from a commercial unit in such that you're using the same amount of power. Well, Richard's talking about there, what's kind of neat about the induction that's a little bit different than the electric resistance, that power boost. Really what you're doing there often is, let's say you have 4 or 5 hobs, the unit's actually able to modulate that power between, like electric resistance, it's kind of just, it's either doing its thing at full bore or wherever you're turning that rheostat to, basically. So in this case, what you're doing is you're actually able to change that around depending, and so the unit can use the power as needed. I would be curious to see, now I'm not in codes and standards or anything like that, but I would be curious to see as they do more studies, or if we push for more studies, There might be some kind of offset though, maybe with building, as you know, there's a reduction in fire risk. So maybe there's potential reduction in insurance costs or things like that if you're going with things that might be just less risky in general. Though I'm not sure yet. I know we do try to use that on the commercial side, because thank you to the chains, because they've been pushing so hard. It can lower our insurance premiums for workman's comp and things like that.
Mm-hmm.
Excellent, excellent. I know there's a lot of questions too about the loaner program. Richard and Mark are talking about it, how you can see them in Northern California. I'm in Los Angeles. I know our utility companies have similar ones in San Diego. The San Diego Green Building Council has, an induction cooktop loaner program. I actually have one at home and I love it. It does boil water. To the point though that was just made of, what does this start to look like with the utilities, especially what happens when there's a blackout and you have a family of 4 and you're trying to feed them and now you have no gas and now your electric and your electricity's out. How do we deal with this? Because I think that's some of the passion and some of the resistance that we see. It's not just about cooking it the way I want to cook it. It's how do I actually cook it if there's an issue here?
Yeah, and just a quick plug on the loaner programs. My buddy Andre Saldivar down at SoCal Edison has a loaner program as well. Contact Andre if you're down in SCE territory. But Miranda, I mean, these are good questions when you're talking about, what happens if there's a brownout or something like that, or a blackout on the electric side. In the commercial world, it is illegal to run your kitchen if you cannot run the exhaust hoods and the dish machine. Okay, so, when your lights go out and all your systems go out, you're not supposed to have a gas range top going. And in California, typically, if you do have a blackout, it's pretty short time, right? You've got power back on pretty quickly. But as you and I discussed, if you're in one of those places where it's kind of life and death, like you're way up in the upper, upstate New York, or way high up in Minnesota or someplace, where you can have a massive bomb cyclone and all the electric lines get blown down and they're out for 2 weeks. In that residential situation, a gas range top still makes a lot of sense. And there's no great answer at the moment, not until we get, battery storage on site in everybody's residence with a, full-on make or break switch so you can isolate from the utility, then all electric works. But it's a totally legitimate question, so.
No, go ahead, Richard. Sorry, no, go ahead.
I was going to say we're in a transition. I mean, when I teach college classes, I tell the students, you're about to see an energy revolution, a revolution in the way the grid works, the way we use energy. We're in that transition now, and there's no perfect one way or the other answer.
I'll give the real world. I worked in Santa Barbara for many years, and it's true. You're not supposed to do that. We were a hotel. We were a fine dining restaurant and a hotel, but regardless, people had to eat. There was literally the hills behind us were burning. The electricity was out. We were cooking by flashlight with gas, and the doors were open. But I think, typically what's going to actually happen there, more than likely, to give the operator's perspective, is chances are if you're in these situations, you're not going to be cooking because nobody's going to be buying your food because you're in obviously a bad situation and like nobody's going out to eat. This isn't a casual thing. But actually what you're wanting to do is you're wanting to close down because you want to keep your walk-ins closed. You want to keep your refrigerators shut. That's where all your money is. And you want I remember having power outages and you're yelling at cooks every time, they're actually consolidating things together and to go into the walk-ins as fast as they can to get back out because you want to keep those doors closed. Mm-hmm. So typically, you're not going to be doing that if you're thinking long-term.
Right.
Yeah, absolutely. I see more questions coming in. We're closing in on time, so hopefully we have time for this last one. People asked about the kind of equipment that you'd actually need to use to cook on this. Do you need different pans? The rule of thumb I was told is if a magnet sticks to it, it's going to work on your induction cooktop. But is there other things that you would recommend in terms of, again, somebody residential or commercially upgrading their cookware to, of course, have an upgraded system like this? And as somebody noted too, one of the pictures showed hot on there. What do we mean by that? Is it actually hot? Because the napkin wasn't burning. So can you clarify a little bit too how that works? So 1-2 on that one.
Yeah, let me start with the hot aspect. So because the cookware is sitting on the glass top, you do get some conduction into the glass top. Okay, so if I'm boiling water in the pot's going to be 212 degrees, and that 212 degree pot is sitting on a piece of ceramic glass. So right underneath the pot will get to 212 degrees. Now, when I pull the pot off of there, that ceramic glass, which is pretty thin, gives up that heat pretty quickly. But in order to keep me from walking up and just setting my hand down on a 200 degree piece of glass, there's a little warning light that's just letting you know the glass is still hot. Okay, but it's way different from that electric resistance range, which has to be at 300 degrees in order to boil 212 water, and which stays red freaking hot for another 25 minutes, right? Or even the burners, you know, the cast iron burners on a gas range. Now, as far as cookware, you're correct, Miranda, if that fridge magnet sticks to it, then it will work. There, you know, we could have another discussion about sort of better and worse cookware, but most of the cookware in people's homes will work. You know, your cast iron skillet is great. I used the La Brisée stuff to make my lemon curd last night. That all works great. The place, you know, the thing that we typically find that's a cookware challenge is in lots of restaurants will buy these really cheap throwaway aluminum, you know, stock pots and stuff, and those won't work. But as Chef Mark has noted, one nice thing about, you know, so now I step up to a little better cookware that works on the induction. One nice thing is that when you go to induction, you no longer have the carbonization on the bottom of your pots and pans. And so they last longer and they're more effective, right? Because putting a pot or pan on a gas range with the burner will carbonize that bottom, particularly on a saute line. And so you're having to pitch those things anyway. So there's another one of the little.
Well, it's that, and also I'll finish with it really quick. If you're on the commercial side, that carbon is also getting mixed into everything. And what you notice when you had we didn't notice it as much until we did go to induction, but that carbon is all over everything. So, I mean, to the point where it was just run of the mill, but we would always have 2 to 3 dishwashers machines. You know, our silverware and glassware went through another dish machine after it went through the main machines. Because there's just buildup on everything, and that goes away. So I think to wrap it up there, the point is that yes, while the units themselves might be more expensive, there might be this investment into other pieces. There's a lot of ancillary benefits that need to be explored that can actually help justify these costs, especially from the commercial food service side. We haven't been very good at amortizing or looking forward, and I think that's hindered us quite a bit if we're trying to be successful in our operations and increase our margins. We need to be definitely looking at this in a more sophisticated way.
Absolutely. And I think it was summed up nicely. We're on the cusp of this revolution here. So big thank you to Richard and Chef Mark for this excellent presentation. If you've made it this far with us, AIA California staff would like you to submit for your AIA CE credit. It should appear in your transcript in a few weeks if you provided your number when you registered. A link to your Zero Net Carbon Design mandatory continuing education certificate of completion will also be sent to you. As always, more resources and tools can be found on AIA California's website, www.aiacalifornia.org/climate-action/. Thank you again for joining us today. And of course, we'll see you on our next Climate Action webinar. Have a good one.
Thanks, everybody.
See you later.
Thank you.